All right, so I left you guys here and I showed you, for now, this is all you have to do. Just write them out. It gets fancier later, but we're going to work on that today, okay? I just wanted you to get the concept down right now. So we remember that our domain is just the name given to the set that makes up our independent variable. Whatever our independent variable may be, that is the domain. We also remember that it is usually on the x-axis, and I forgot to mention this yesterday, it often gets another name of input. And if you guys, input, output. Yeah, I was just going to say, if you guys remember back to, I was going to say grade 5, but if you remember back to about grade 5, your textbook might have drawn something that looked like this. And you'd put a number in there, and then there would be another box here that said +7, and then another different shaped box here that said -4, and then another box here that had this, and this would be your input, and this would be your output. I'm talking about textbooks from like 30 years ago when I had them. And you would put in the 12, you would add 7, you would take away 4, and you would get out 15, right? Your input was 12, your output was 15. And then later on, we started calling it X and Y. That's all that is. So your range is your Y-axis and your output. So we came down to this second one here. And what were our domain values, which I'm going to do in blue, and my ranges in red? What were my domain values here? Put the littlest one first. -1, 0, 1. Now the problem you guys get here, what messes you up, is you see that you have 4 X values here. But you technically only have 3 inputs, right? Because it's 1, 0, -1, and then we had 0 again. So we just write each value. We don't write each ordered pair. Does everybody understand that? Because the value is all we care about in the domain and the range. Cool? And then we do the same thing for the range, except again we put it in order, -1, 0, 1. Now what happens on these that messes you guys up is you think that this is an ordered pair. Is it? Is -1, -1 any of our points here? No. So you got to remember, once you separate into domain and range, it's no longer X, Y. All right? Does everybody understand? Now up here, it happened to work X, Y. Does everybody understand this? All right. So this one, my domain is 2, 4, 6, and 8. And I'm keeping my domains in blue and my ranges 3, 5, 7, 9. Again, it happened to work out with ordered pairs, but it is not always an ordered pair once you have split into domain and range. Everybody cool? All right. Now, what changed in D? We had a graph, but each graph still had ordered pairs, right? This guy, we wrote out, this guy was -3, 2, this guy, and there is another set. What was this guy? Was 0, -2. This guy was 1, 0. This guy was 2, 1. And this last guy was 3, 1. So what was our domain over here? -3, -2, 0, 1, 2, 3. And what was our range? -3, -2, -1, 0, 1, and 2. And see, this one doesn't work out as ordered pairs. Is everybody okay with either values, dots on a graph, and the other thing you need to be okay with is real life situations like hours and wage? Can everybody handle domains and ranges for those three things we've done? You haven't had any practice on it. If I were to say try a couple right now, do you feel you could get started? Everybody? Okay. So turn the page over. We've just got to do a couple more things with this, and then you're going to do some work. The vertical line test. The vertical line test tells you if you have a function or a relation. What's the difference again? Anybody? No one? Yeah, a function, every element matches with one other unique element. In a relation, it's not necessarily true. Okay? If I were to relate you people to your ages, would it be a function or a relation? It would be a relation because you all share ages, right? But if I were to match you people to your name, what would it be? Function, because there's only one Rihanna. I don't say your last name right, so I'm not going to say it because he'll get mad at me. So I'm not going to say your last name, but it starts with a B, ends with an R, has UTTA in the middle of it, and spell it. I don't want to say it. Latar. See, I had to say it quietly enough so you wouldn't hear me and bug me. But I got the microphone right here. All right. Tells you have a function or relation, the vertical line test. But there's a catch. It only works on graphs. So if you ever have a graph, you can do this test. Okay? And it's very simple. If a vertical, what's vertical? Right. If a vertical line hits the graph in more than one spot, you have a relation. And that makes sense, right? Because the vertical line is the y values, yeah? And the y values are the range, the y values are the output. So if a vertical line hits two spots on the graph, that means wherever you are on the x, you have two outputs, and that's no good. Everybody with me? Here's what it looks like. So I'm going to make a graph right there. I'll put a red line in. That was a bad red line. There's a graph, yes? What happens right there at that vertical line where x equals 1? I have a value there, I have a value there, and I have a value there. So this would be a relation. Everybody cool? Yeah. Now, if I had this, that vertical line only hits, I should have made it red. Sorry, I'm such an idiot this morning. And my computer's frozen, freezing my idiocy in your mind right now because I cannot fix it immediately. If I drew this line, you can see that a vertical line only hits the red at any given time once. So that's a function. I don't know why I started this way over here and left all this blank space here. I'm an idiot. Everybody cool? But remember, this only works when it's graphed. Okay? All right, so let's look at our very next thing here. It's a little hard to see on my screen, but I think it's pretty easy to see on your guys. You have the dots, yes? Right? Okay. So if I were to take a vertical line and slide that line along the graph, what happens right there? It only hits one dot, yes? What about there? It would hit one dot if it would stop there. What about there? Hits two dots. Is it a relation or a function? Okay, excellent. So this is a relation. Because what happens here and here? At input of -1 and +1, we have multiple outputs. I don't know why my T crosses are disappearing. And my I. And they're still disappearing. So I'm going to go ahead and shut this down. Then I'm going to open it back up again. All right. Everybody cool? Okay. So now what I want you guys to do is tell me the domain and range. The domains are which? The domains are X's or Y's? X's. So what are my X values? Do I start from the least or the greatest? Least. So what's my lowest X value? -3. Now, what's my next X value? Then what? -1, then 0, then 1, then 2, then 3. Is everybody cool with that? All right. What are my range values? What's the first one? What do I start with? -2. Excellent. Somebody usually says they should start with 0 because we started over here on the domain. But that is not the case, is it? We start at the lowest. What's next? Then what? Then what? Then what? Then what? 3. Now please notice 1, 2, 3, 4, 5, 6, 7 domain values, but only 6 range values. Right? And that's okay because these are not ordered pairs. Everybody with me? All right, now we do one other thing here. When we do domain and range, because when we write numbers like this, if we put them in brackets, then people think we're doing math with them. If we put 2 numbers in brackets, then people think that it's an ordered pair, right? So you remember back before emojis came out, you had to type your emojis? You guys remember this? And the smiley face was colon, bracket, and then colon P for sticking your tongue out, like on that episode of Victorious. Right? There was another one where you could make the devil horns with that squiggly bracket. That's what we use here. We use those squiggly brackets. They're a bit of a pain to draw. If you can't draw them very well, just make squiggly lines. And I'm happy with that. Okay? It's just to differentiate between brackets, parentheses, and these. Everybody cool? Good? Okay. Now, something different happens here. And I'm going to shrink the view down a little so you can see both of the previous two questions at once. What is different in B than A? It's a line, isn't it? Right? So in B, if I told you go to x, the x value of negative 2.5 in A, where is negative 2.5 in A? It's right here, yes? Does everyone agree? Okay. So if I asked you for the output at negative 2.5, is there one? No. Everybody with me? And there's no dot at x, negative 2.5. So this point right here doesn't exist on this graph, does it? There is no input of negative 2.5, so therefore there can be no output, right? What about this one? At negative 2.5, is there an output? Yes. What about at negative 1.5? Is there an output? Yeah, right there. What about at negative 0.7? Yeah. What about at negative 0.31? Yeah. Everybody seeing where I'm going with this? In this one, that's just a bunch of dots, we list them. But in this one, every single value from here all the way to here has an output, doesn't it? So we got to write our domain and range differently here. And we're going to explain that in a minute. You've already seen it when we did the hours thing. But first, is this a function? If I draw that vertical line, does it only touch the blue line once? All the way along? Yes. So we know that this is a function. You also know that that word says function, even though it is that letter that doesn't exist, unc, L, no letter, and an on. It's an unklon, according to my very high quality piece of technology. There we go. It is a function, yes? Because for every input, I have one output, right? According to the vertical line test. All right, so now we got to talk about how we do the domain and range here. And I'm going to go back up to full size so it's easier for you guys to see. Now, you guys think about this for a sec while my computer thaws. If I have every single value of x, how can I write that? Could I write it this way? Is that possible? Yes or no? Would it make sense to write this guy's range or domain in this form? No, why not? The decimals make it impossible, doesn't it? Because there is an infinite amount of decimals between any 2 points, isn't there? So we couldn't write it this way, could we? So we've got to come up with another way to write it. So the first thing I like to do when I see a line is I like to do this. Domain is which axis, x or y? X. So what I like to do when I see a line is I go to the lowest or highest point. Lowest x value, and it's right there, yes? And I only care about the x-axis, don't I? So that is negative 3, right? So I put my squiggly bracket, and I put negative 3. Does the graph get to negative 3? Yeah, there's a dot right there. So negative 3 is certainly an x value that we have, yeah? Now, what I like to do, because I'm only doing domains, is I like to take my blue pen and I color along the x-axis until I get to the end of my line. And it ends right there, doesn't it? What value is that? 3. And then I just do this. My x values have to be, negative 3 is lower than or equal to my x value. And my x values have to be lower than or equal to positive 3. Does everybody understand how to read that? Everybody cool with it? You remember these less than and greater thans from like grade 4, except your teacher called them alligators or Pac-Man or something silly like that. And, huh? Big fish. There's always a nickname for it. What they really are is less than and greater than. Right? Everyone can read that, right? And this is what we call set notation. Okay? Now that's cumbersome, right? It's a pain in the ass to write that, correct? So math guys, being the lazy guys that they are, they invented another way to write this. If you have a line and everything is colored like this, you can write it this way. A square bracket, -3. That means, that square bracket means we actually get to -3. And then a comma, and then up to +3, and we write another square bracket. And this is what we call interval notation. Okay, you got to be able to understand how to read both. And of course, I'm going to ask you on a test to do one of each to show you know. But let's say on some of your homework, there's like 8 questions about domain and range. Do I care which one of these you use? No. As long as you understand both. Picking up what I'm putting down? It's like I know how to drive a standard car, but I don't happen to have one right now. But if I have to hop into one, I can drive it. Everybody with me? All right. So, knowing what you know about domains, how would you do the range in both of these? Range is on what axis? Y. So where do we start? Highest or lowest Y value? Lowest. Where is it? Right down here. And what value is that? -2. So I put a squiggly bracket, -2. And then I do the exact same thing as I did with range. With domain. Since this is a line, all of this is covered, isn't it? Up to where? +3. So -2 less than or equal to y less than or equal to 3. Squiggly bracket. There's my set notation. And what would it be in interval notation? What kind of bracket? Square, because I actually was at -2, wasn't I? -2 up to what? 3 square bracket. Is everybody cool with both of those? Yeah. We're going to practice them, so don't worry if you're not totally on. Everybody good? Can I turn the page? Okay. Look at 146 and tell me what's different. Or C and tell me what's different. There's 2 lines. That's one difference. What else is different? There's negatives, so it's not 1, 2. It's -10, -20, right? That's a second difference. What else is different? What do you see there? A circle instead of a dot. Who remembers from the 9th grade what that circle instead of a dot means? I'll remind you of this. X is greater than 7. What does that dot mean? Or that circle instead of a dot mean?
The dot means it can also equal 7.
The dot means it equals 7. The circle means it equals almost 7. Like 7.0000000000000000001 would be okay. But 7 is not. Everybody remembers that from the 9th grade? This is where it applies now. Okay? So, remembering what you remember from the 9th grade and noticing, so we've got those dots, we've got 2 different lines, and we've changed the scale, yes? Do you think what we do changes? No. So what is our domain? We always start on the x-axis. What's the lowest x value we have? It's right there, and what is it? -12? negative 30. So my domains are going to start squiggly bracket, negative 30, yes? Is that a dot or a circle? Dot. So is negative 30 included? So it must be equal to negative 30, right? And then we follow along until we get to the end of the line. And it ends right there, doesn't it? Is that open or a closed dot? Open. So is negative 10 included? No. So can we use this equal sign? No. We have to use a regular less than 10. Does everyone see that? Then I put a squiggly bracket because it stopped there, didn't it? Is there any inputs here between negative 10 and 0? Any inputs there? No. But then what starts again at 0? It starts up again, doesn't it? Open or closed dot? Closed. So does it get included? Yeah. So I got to have another range value that has 0. What sign? Less than and equal to, or just less than? Less than and equal to, because it's a closed dot. X. And what does this one go up to? 30. Does it hit 30? How do you know? Open dot. Squiggly. Now we have two different sets, don't we? So we put this big U here. That means this is part of the domain and this set is part of the domain. It's two different sets to equal the whole domain. The U stands for union. Everybody okay? Everybody good? Okay, so how would I do this in interval notation, do you think? What would be on the far left? Negative 30. Did I actually hit negative 30? Yep, so I put a square bracket. Then I went up to 10, right? Negative 10, yeah, negative 10. Did I hit negative 10? So I can't put a square bracket. So I put a curve bracket. Not a squiggly bracket. This is very detail-oriented. It's a pain. Everybody cool? Yeah. And then I put the U, because it continues on. Did I hit 0? So is it a square or a curve bracket? Square, 0, comma, what did I go up to? 30. Did I hit 30? No. So what kind of bracket? Curved. A parenthesis. Everybody cool? Okay, now you guys try it with range. What's my lowest range? Don't say it out loud, just try it. I'll wait a few seconds while people who are going to try it, try it. Okay, what's my lowest range value? Negative 20. Do I hit negative 20? How do you know? Closed dot, so it's less than or equal to. Then I go up to what? 0. Do I hit 0? No. So y value gets a regular one of 0, squiggly bracket. Is there more range? So I write a union. Where does it start again? 10. Do I hit 10? No, because it's an open dot. So it's a less than y. And what's the biggest y value I have? 30. Do I hit 30? Squiggly bracket. Now how do I put that in interval form? Did I hit negative 20? So I put what kind of bracket? Square. Did I hit 0? No. So what kind of bracket? Curve. Union. Did I hit 10? No. Curve. Up to 30. Did I hit 30? So square. Is everybody cool? Yeah? Everyone's good? Okay. Now, what's different in D? Because D puts everything we've done on one question. If you can figure out D, you know everything we're doing. I don't expect everybody to be able to figure it out. First of all, is it a function? Let's check. Take my black or my vertical line. Slide it along. Am I okay? Okay. What happens there? It looks like I hit 2.
But you didn't because it's
That's an open dot. So does that spot really exist?
no.
No. So are we okay here?
Yes.
So we're still a function. All right, now let's check our domains and ranges. They get weird. What is my smallest domain? Look closely. -5? -6. 3, 6, 9. It's divided in each square is worth 3.
Oh, yeah.
Okay? So, do I hit -6?
No.
No. -6 less than, yes? So now I'm only checking my x values. I go to here, and then what happens immediately? Does it start again? Yeah, so I keep going. Even though it's 3 lines, I'm only looking at the x values, right? And every time one line ends, it starts again right away, yeah? So what is my upper limit? 6. Do I hit 6? 6. How do I write that in interval notation? Curve bracket, -6, 6, and square bracket. Is everybody cool? All right. Now, what's different about the range here? I have a value there, right? Do I have anything in here for range? Are there any y values between 3 and 6? No. So my range is 3. What's the next one? What's that? Because that's my next y value. 6. And what's that? 9. Can I do this or an interval? No, because I never colored any of the line, did I? I only had values like we had back here where it was dots. Is everybody cool? Okay. So this is our range. I can't do greater than, less than, and I can't do interval notation because there's no interval. It's only single values. Yeah? All right, now listen. I'm going to give you guys not a ton of work, but a bit of work. And I'm going to let you work on it for a while, then we're going to go over that test. Okay? Page 147 and 148 are textbook pages. You've got the answers there. Okay? As always, do at least a couple of them and make sure you're getting the right answers. Because if you're not ready to move on, okay? Then you will notice on page 149, you have 12 domain and range questions. Okay? Everybody cool? For these, I want you to do half of them in set notation, and I don't care which half you do, and half of them in interval notation. Okay? I don't care which ones you do with which. But some of them you're not going to be able to do interval notation with, right? I think all of these are intervalable. No, like you couldn't do interval notation here, could you? Because it's all dots. All right. And you have to look a little closely at things. Notice this arrow. What does that mean? What does that arrow mean? It keeps going. For how long? Ever. Right? And you have to make a decision here. I'm going to help you guys out right now. This goes flat. So everybody please turn to page 149. Let's set a couple of these up. This one goes flat right there. It doesn't go any more down. Okay? This one, flat again. Number 5. Number 5 flattens out. And then the rest are pretty self-explanatory. Okay? Everybody good? Now, tomorrow when we go over this, we're going to talk about what would happen in number 2 or number 3 and number 5 if it didn't go flat. Okay? It's so easy. Like, it makes perfect sense. You don't even need me to really explain it. You'd be like, oh, right, duh, of course. All right? Everybody cool? What? Actually, you know what? I'm going to change this again. I'm the worst kind of person. Just make those arrows closed dots today. Just make them closed dots, because then tomorrow I can cover both what would happen if it was pointing up or down, and if it's an arrow. I'll cover them both at the same time. Everybody cool? So make 3 and 5. Just make them a closed dot at the end. Are you doing this? Okay. Everybody good? All right. I'm going to shut up till, 9:15, 9:20, and then we'll go over that test. Because I want you guys to see it, because there's a couple of things about it that people are a little dodgy on still, more than a few of you. Okay? All right. Yeah, we'll go over that around 9:15. Stop recording. Oh, wait. I'm not going to stop recording yet. So you are working on pages... 147 to 149. 150. Yeah. Pages 147 to 150, 147 to 148 are textbook pages. So they've got the answers there. Just make sure you do a few of each one. Make sure you know what you're doing, right? And 149 to 150, you want to do all of them. Everybody cool? And 149 to 150, you're doing domain, range. Oh, and you might as well tell me domain, range, and if it's a function or a relation. Cool? Go. Now I'll stop the recording.